Hi, hello everyone. See you guys again. Welcome to my channel. This is the second video related to how arrays are implemented in JavaScript, and I will use V8 JavaScript engine as an example. In this video, I will focus on talking about elements kind. Here we talked about arrays. In my previous video, I mentioned about arrays use index properties, and people in V8 we call them elements. Okay, for index properties, which the index array like index is 0, 1, 2, 3, 4, which is integer index properties. Okay, and they have a special name called elements. And here we will talk about element kind. And also you will learn another part is related to element kind called packed and Holey. And this will be related to the fast array and the slow array. Okay, so now let's move on. The first thing before we head into the element kind, we have to I just briefly introduce about numbers. So as we know, ECMAScript expect we use 64-bit to represent a number, right? And does it really are all numbers be presented in memory or use 64 position or 64-bit in V8? Have you thought about it? And the answer is no. Okay, the reason is because numbers can be represented in memory in many ways. Here I show some of them, like 8-bit, 32-bit, and 32 position and 62 position you can use in bit. Okay, for a single precise floating number, for double precise floating number, and ECMAScript expect agreement tells all numbers in JavaScript are using what? 64 position double precision floating numbers. And from this table we can know if we represent only 1, 2, 3, 4, 0, 1, 2, and those numbers all use 64, those double precision floating point, it's gonna be very slow, right? And it's not necessary to use 64-bit to represent all numbers inside JavaScript. And we also need to we need to follow the specification. And what V8 do is, first, inside the V8 JavaScript engine, not all the numbers are used for 64-bit to represent. Most of them are used 32 for performance issue. But from a developer view, you cannot tell the difference. But under the hood, actually, V8 will treat numbers differently because V8 is written in C++, right? And it has a different type of numbers. It will have integers, it will have double, and that will bring the next topic. Okay, inside the V8 will keep track of what kind of elements each array contains for optimization purpose. Inside the V8, total, if I remember correctly, yes, I remember correctly. Total V8 actually differentiate. My pen, I know. It differentiated. It will keep track. It have 21 different types of element it will keep track of. And here we only talk about 81, which is related to our array. Okay, 8 of them. Those are packed semi elements, packed double elements, packed elements, Holey semi, and Holey double, and Holey elements. First one, I will explain this, and this one that I have. Okay, so semi stands for small, integers. Okay, SMI means small integers, and those integers are using 32-bit to represent it, like 0, 1, 2, 3, 4, those elements. Double are represent for those floating elements. So let me show you one example. What are they used? Okay, what are those being used? For every array, and based on the elements you stored in the array, and the V8 will give a different kind of like a label to the array. Okay, the type of the array, it will give different label, and those are the label being used. Let me show you, and not only them. I will show you here. I will show you here. Okay, so I will go to the node, because without node we cannot see, right? Here, let me start from scratch, because some people probably didn't see what I did. Okay, the first one is you have to use a node, allow natives syntax. This option will enable one method called debug print. And the first one, I will create an array equals a thing like a 1, 2, 3, 4. All of them are integers. Okay, then I use debug print and ARR, and here let me show you what it is. Okay, see here, the map here use, see here, packed semi elements, and here elements here, and they use packed semi elements, and that is the first one. Okay, and now let me show you a second one. Const AR2, and for this array I will have what's thing 1, 2, 2.5, 5.6, and not 8. Okay, and then I still using the same method, debug print and ARR2. And take a look at here. Take a look at it here, what it is. Okay, here, see here, debug 2, and here you will see here what it is. Elements here is packed double elements. The reason is in this array, okay, if you have 1, which is a floating number, okay, then it will be a double. Okay, only when all of them are integers, you will see packed semi. Okay, let me show you another 3. Okay, equals 1, 1, 2, 3, 4, and I just add 1, 89. Okay, and then debug print AR3, and here you will see here packed double elements. Okay, that is this one. That no here. That is this one and this one. And what about the elements? Okay, what about the elements? Let me show you. Suppose in your array you contain something which are not numbers, like you contains a string. Then it will have, it will use like 1, 2, 3, 5.5, and even then I can do like this way. AR4 dot push. I push 8. Okay, and when we type AR4, you will have a letter there, right? Then we use debug print AR4. Okay, and now let's take a look at. Let's see here, packed elements for this one, packed elements. Okay, and that is this. Okay, this part, semi, double, and elements. Now let me explain about packed and Holey. Okay, if you still remember what I demoed about array in previous videos, and you already see one example actually. The reason is because when we give the length of the array, right, it's actually is an index of +1. It's not the actual length, it's index +1. And if we create an array like this way, I will do in the console. Let me do in the console. It's very low here, okay. New array, okay, equals empty array, okay. And then I use new array using like this way. 0 is a, okay, or new array dot push b, okay. So now I have a new array. Let me print. You will have AB. And now let me do like this way. Okay. First, I will do a debug print new array. And you will see here still is the not here packed elements, right? New array. Here is a packed elements. Okay. Packed elements. Let's see here. Element kind is a packed elements here. Element kind packed elements. Okay. But now if I do like this way. New array, I do like this way. And now I use debug print. And now let's take a look at. Hey, see here, Holey elements. What happened? Let me use one note to explain to you guys. Okay, so here what we have. This is. Let me create another one. Previously, what we have, let me see if this one works. Okay, I have to unplug this one. I can use a pen. It's gonna be faster when I draw. Okay, I put it here. So, what I did, the steps is a const new arr equals empty, right? Then I did one step is arr 0 equals a, and I did a new arr dot push, which equals what? Equal push b, not equals. Then I did new arr 10 equals 10. What's gonna happen? Yes, after this one, the air is empty, and after this line, my array become like a, right? Like this way. And after this one, my array becomes what? My array becomes A and B, push add into the end. But after this one, what's gonna happen? My array gonna be look like what? My array gonna be look like this way. A, this index is 0, this index 0, and B, index is 1, and here we will have 10, but this index is 10, right? The 1, and how about index on 2? How about index on 3? How about index on 4? How about index on 5, 6, until 9? And how about those index? What's the value to them? And here in the memory, here didn't store anything, and this one is called a horse, because in this case, based on what we did here, we create a horse inside the array, and that is called a Holey array. Okay, because here between 2 and 9, you didn't add anything in the memory for them, and we create a horse here, so it's called a Holey elements. The reason here we have a Holey elements, under this one, the type now become Holey elements, because inside this array we have A and B, which are string. That's why it's called Holey elements. Okay, if it's a Holey, if I have a constant arr new arr 2, okay, and equals an array, and I just use new arr 2, give 5 equals high, like this way, and then I use not high, because high is all string. I have to use 3. What I'm doing, and the const new arr 3, and give 4 is 1. Okay, and then if I use a debug print, new ARR3, and you will see it's called the element kind here, element kind, Holey semi-elements, and also here, Holey semi-elements. Because just now what I did is I create an empty array. I just assign value to index 4. But for index 0, 1, 2, 3, I have a hole there. I didn't assign anything there, right? So it's called a Holey semi because I only have an integer here. If I create a last one here, okay, new ARR5 equals an array, but new ARR5 here, which is 6. Okay, I give a floating number 9.54, and now we use the debug print, which is new ARR5, and here you will see element kind like Holey double elements. Okay, so that explains the difference for the 6 kind, packed and Holey, which means in an array you didn't have any holes inside, okay, which is an index, you didn't do any operation, and then it's gonna be packed, otherwise it's gonna be Holey. Semi, which means all the small integers, which are 1, 2, 3, 4, and if all the elements in the array is a semi, it's gonna be all the elements are integers, it's gonna be semi. And if not, it's gonna be if it has a floating number, it's gonna be double. And if you have anything else, it's gonna be packed elements. And same for the Holey, this part, okay. And when are they be? And also when you push new elements into the array, and from one type of the element kind can be transferred into the other one here, and inside of V8, okay, they use some math paradigm to represent how the transition system works. Okay, it's called the ladders. Okay, ladders, okay. V8 implements this tag transition system as ladders. It's used also in math. And here is the thing. And it's only possible to transition downwards through the ladders, which means from packed semi elements, it can be transferred into a double. See the arrows here? Packed double can be transferred into the packed elements. And the packed semi can also be transferred to a Holey semi, and a Holey semi can be transferred to Holey double and Holey elements. You cannot, okay, this one is transition downwards, means what? An array cannot transfer from packed elements into packed semi elements. It cannot transfer from Holey elements into packed elements. You cannot do. It can only do the ways as the arrow sign doing here. Okay. So now let me show you how are they transferred. Let me bring the node platform. Suppose now I create array 1. Okay, equals like this way. Now let's take a look at debug print array 1. Okay, and here you will see element kind is a packed semi. Okay, now if I do like this way, array 1 dot push 1. Okay, push 1, and now we debug print, you will see still packed semi. Okay, now I will push another one, push 2.5, and now I use debug print. You will see now the element kind is a packed double elements, which means what? Which means from packed semi elements it transfer to packed double elements now. And now we will do push like a miss Xing, which is a string. Okay, and now let's debug array 1. Now you can see the element kind is packed elements, which is here. It's a packed elements. And when we on the packed elements, we cannot go back to Holey semi. Okay, it only can transfer is called the Holey elements. Now let me transfer to Holey elements. We do not use push, and here we have indexes 0, 1, and 2. I will add array 1. Directly use the index, which is 10 equals 10. Okay, I'll do like this way. Now I'll use debug print array. Now you can see the element kind is Holey elements. Okay, and also here is also Holey elements. That is this one. And now I will do another example is a packed semi elements to Holey semi elements. Okay, and then all the way. So here I will have another array because I cannot change on the array 1. Array 1 is already Holey elements. We cannot go back. Okay, I will do is this one. I will add this like this way. 2.5 2 2. Okay, 2. Okay, and then array 2 dot not a dot 5 equals 1, and then I will have a debug print array 2, and here you will see it's Holey semi because I have 2 as index 0 and I have index 5 is 1, but I have 4 empty items. Okay, from 1 to 4 the index I do not have anything. That is Holey semi elements. Now if I from array 2 I push another one, array 2 dot push another floating number like 3.5. Okay, now I use debug print. It's gonna become Holey double because I have a floating number now. And now next one is what's thing. Next one is the last one. I push another one. Okay, array 2 dot push another one which is ABC. Okay, and now I will debug print array 2. You have see Holey elements, and when it's Holey elements you cannot go back. Okay, and last one I want to show you which is here I talked about a fast array and a slow array, right? And the difference, what are they? So here, when you see here Holey elements and Holey packed element, Holey semi, Holey double, they are still kind of like a fast array. Okay, even though packed semi is faster than Holey elements, right? But they still have a linear continuous storage in the memory. And what is slow array? Let me show you one example. Okay, const ARR equals like 1. I do like this way. Okay, and I have ARR already. I will do const names. How about the names? Okay, I will use 1 here. Okay, and now we will use debug print this array names. Okay, and you will see it's packed semi, right? Even give by the name. Okay, even though it's called names, I give the integer. It's packed semi elements. Okay, now I will do like this way. Two is fine. Okay, now I use debug names. Now can you see here? Can you see here? I just add this one, and now you can see here dictionary elements, and here element kind is also dictionary elements. It's not anything I store there. The reason this one first one, the dictionary elements is also what? Yes, also is this slow array, and which is use a hash table to do the storage. The reason for that is what? I think you can guess the reason now. The reason because originally in this array I only have 1. Okay, I only have index 0 has 1. Then I have another value being pushed, but it's on the index is 10,000. And between index 0 and 10,000, I have too many holes. And this will create an array called a sparse array. Some people using this word called a sparse array. And this array is too sparse. Because this array, we're gonna do what? I have index is 0, and after that I have 9999 holes, and then at the end I have 22. And JavaScript V8 say, okay, that is really bad. If I have a continuous storage to leave continuous memory being allocated for this array, and the size I have to reserve is for 10,000, but you only have two numbers. It's kind of a waste, right? So array do is, okay, in this case, I will do a regular object and a dictionary hash table. Or the dictionary, you can think this one is just a regular object, JavaScript object, which is index 0, yes, what? 0, and index 1000, yes, 22, and all others ignored, okay? And that is called a dictionary, that is called, dictionary elements, okay? And which is also used for arrays. And it has a fast array, it has a slow array. Slow array is use a hash table. Mostly, yes, you have your array data is very sparse, okay? Let me take a look at the slides, okay? So here in this video, I just explained how the arrays are being marked in different of type using element kind, okay? And next video, I will show you how those affect the performance inside the V8. Because why V8 label them must have some reason, right? The reason is because of performance issue, okay? So hope you understand, and I will see you next time. Bye bye.